Okay students, actually we are continuing the same question because that question was a bit long question, although numericals, but it's a bit long question and it has been asked so many times in board examination. So I found out the field outside point, field inside point that we have found out, and on the basis of this we have drawn the graph also, BR versus R. R is the distance from the center of the wire, and we have seen that as long as it is inside, it is BQ is directly proportional to R. That means up to the surface it goes like this. Here the value is maximum. Okay, at the surface the value is maximum. You can prove it by graph also, by numerically also. And after that it falls because BP is inversely proportional to R. It falls like this, and what happens? It does not touch because it is inversely proportional to R. So its fall will not be very much steep fall. It's a gradual fall. You have to be careful in that. And here it goes parallel to this because when R will be infinity, then only B is equal to 0. That's why it goes parallel. You have to be very careful in plotting this graph. Although this graph is not very difficult, but we have to be careful. This is the first part. Second part is also there. Now we are coming to the B part of this question. Let us come to B part of the question. Part B. Here I write here part B. For that, calculate the ratio of the magnetic field at a point A by 2 above the surface of the wire to a point A by 2 below its surface. One surface here, this is the wire, its radius is A by 2, just half of it. Suppose there is a point R, A by 2 below it is S. Okay, we have, it is outside point, it is inside point. Okay, for this, what we shall do? For the outside point, for field at R. Okay, I put to field at capital R at this point. What we shall take? R is equal to A by 2. Isn't it? R is equal to A by 2. Outside point here. Sorry, not A by 2. This whole distance from here, from center to the distance is R. So R will be A plus A by 2. I hope you got it. Because what is R? R is always taken from the center of the wire. So center to the point R, capital R. So how much will be? It will be A plus A by 2 means how much? Thrice A by 2. That means what is BR? I shall put it here. Mu naught I divided by twice pi into thrice A by 2. 2 and 2 cancels. How much you are getting? Mu naught I by thrice by A. Now here for this, for field at S, what will be R? R will be A by 2. A by 2, because from the center the distance will be taken. That should be A by 2. How much will be? BS should be mu naught. Here this formula I. What is divided by? Twice pi A square. And into, here it is, I can write A by 2. This A and this A will be cancels. Mu naught I by 4 pi A. Alright, and it has been said you have to find out the ratio, that is BR divided by BS. BR divided by BS, I hope it should be 4 by 3. Very simple. It can be proved that it will be equal to 4 by 3. Isn't it? I hope all of you got the solution. This is the part B of this. Once you will refer to this whole question once. In case of any doubt, you may ask definitely. This was regarding that question number 14. Let us now come to another important question. Another important question. This is the question number 7 of NCERT, that is question number 4.2n. In assignment, it is question number 7. You can refer to the assignment, question number 7. Followed? And in the NCERT, it is question number 4.21. Let us see in question number 4.21 what it is said. A straight horizontal conducting rod of length 0.45 meter. You can see its mass is 60 gram. Its mass is 60 gram. Okay, mass is 60 gram. Is suspended by two vertical wires at its ends. Two vertical wires. One vertical wire, two second vertical wire. It is suspended like this. Followed? Okay. Then it is saying a current of 5 ampere is set up in the rod. Okay, I is the current. Since in the question nothing has been specified regarding the direction of the current, I am definitely taking the current from left to right. Normally it is taken from left to right. Taking it from right to left is a bit absurd if it is instructed, unless it is instructed. So I is set up in the wires. Now, first part of the question. What magnetic field should be set up normal to the conductor? How much magnetic field should be set up normal to the conductor? Look, normal to the conductor. In order that the tension in the wires is 0. Now the thing is, tension in the wire should be 0. When the tension in the wire will be 0? First I put that condition for tension in wires to be 0. Okay? The gravitational force should be equal to the magnetic force. You know, gravitational force means what? It will be Fg. Gravitational force means weight. Gravitational force should be counterbalanced by the magnetic force. That means gravitational force is fixed. It is always downward. Magnetic force must be right. Must be upward, sorry. Then I have to first check the field configuration which I have taken. Current configuration which I have taken. According to that, is the magnetic force be on the upward direction? Because actually Fm must be in the upward direction. It has to be. It has to be. Then only it can be counterbalanced. So for that, what I will do? Fleming's left hand rule. Fleming's left hand rule. Let us apply. This is, look, field. Here it is. Yes. Look. Coincidentally, look here. I hope all of you are remembering Fleming's left hand rule. 4 finger into. I have taken the field into. Because according to the question, the field may be out also. Field may be out also. But we are taking field into. It should be like this. Current is like this. Force is upward. Okay. This is correct. This figure is correct. In that case, what I will do? Obviously, mg should be equal to ILB. Okay. I hope B is equal to mg by IL. I hope all of you are having the book. You will see value of G is 9.8. M is given 60 gram. It has to be converted. And then I into L. I think you can find out its answer. No problem. Okay. Then it said in the next case. What does it say in the next case? Let us see. In the next case, it says, what will be the total tension in the wires if the direction of the current is reversed, keeping the magnetic field same as before? It has been said, don't consider mass of the wires. Means consider the wires to be masses. Okay. Now in the second part, now we are coming to the second part. For the second part, what will happen? Now in the second part, the current is reversed. Look, you can draw the next diagram. You can draw the fresh diagram. What I make? Current to be like this. Okay. In the second part, the current will be like this. Clear it is? If the current is reversed, be careful. I have reversed the current. If the current is reversed, then what will happen? Look here. into current in this direction, in this direction. Now this is the second diagram, fresh diagram, second diagram. You can draw the second diagram. In this case, FM will also be in this direction. Alright, clear? FM. So total tension in wires. Total tension in wires, how much it will be? If we take total tension in the wires, better we take capital T, will be equal to how much? Or better total tension means F you take, that is equal to Fg plus Fm. Right. Now see, one thing you just find this. I have considered already Fg is equal to Fm and accordingly I have found out the value of B. So Fg and Fm are equal. That's why you can find out the value of twice Fg also. How much? Because as Fg is equal to Fm, already the condition has been put. But mind this, in both the for both the parts you change the diagram. Diagram has been changed. For the first part, Fm was in the opposite direction, current was also in the opposite, and in this case, the current has been reversed. Magnetic field is the same, but magnetic force is also reversed. Be careful, in this way it will be solved. It is also an important question. So many times it has been asked in the board examination. Okay.